Okay, we're talking about introduction to databases. And when you look at the space of IT, database is a very, very important and a critical tool for the business perspective. Very important because of the kind of impact it has on the business. So as an IT expert, you will also try to understand how to manage databases at enterprise level and database availability. So I'll just go through the introduction about databases and why database is important, and we'll do some hands-on section. So I'll be guided by this outline. What is database and database management system, structured and unstructured database, relational database, Nosql database, relational database design, the workload, OLAP and OLTP, then database objects, about database table, indexes, procedures, function, and triggers, then queries, and the lab section. So deep dive into database and database management system. So from the word database, the first part is what? Data. So data just literally means you taking record of facts or of an event. Let's say you have a group of students. You decide to take their heights, their weights, and their skin complexion. You can refer to that as a data. Then the database, when you talk about base means like a structure when something is built on. So you can say database is an organized structure that holds or store data. And for example, an attendance sheet in a classroom, maybe when a lecturer walks into a class and requires that the class governor or the class captain gets the list of students present in that class. So that spreadsheet can also be referred to as a database. Now, because of the limitation of such kind of database, we have a database management system. What is the database management system? It's just a software that assists in organizing collection of structured information or data and store them electronically in a system. That is a definition from Oracle. Microsoft says a database is a tool for collecting, and organizing information. So database management system. Now, like I was saying, database is a software that's aid in keeping our data in an organized structure. So one of the advantage of database management system, for example, like I gave an example of a classroom attendance sheet. Now, a classroom attendance sheet, it cannot be accessed concurrently. Maybe it will be accessed only a user can access it at a point in time. For example, maybe 5 students want to know, or 5 lecturers want to know people that attended the class in a spreadsheet. It's when one is done with that attendance before you can pass it over to the next person. But a database management system serves as an interface whereby multi-users can access a data concurrently, just like our mobile application, a mobile banking application. Different people or customers to a particular bank has their mobile application, and they can check their balances, they can do transfer concurrently, regardless of what the other party is doing. So that's one of the advantages of having a database management system. So example of database management system, talk about Oracle database, Microsoft SQL Server, MySQL, Mongodb, many others. Now we talk about types of database. Now, types of database depends on the kind of data and the kind of structure of data they store. Databases are generally grouped according to the type of data they store. You have structured and unstructured data. Then we'll go deep into structured data. Structured data is the data that is known, that has a known format and is stored in that predefined format. It is highly organized and easily understood. So, a structured data is known to have a predefined format. When when the data is being passed to the database, it comes in a predefined format. For example, attendance sheet in a classroom, you have them in a tabular format, whereby the first row you record the first student, the second row you record the second student. So in that pattern, is structured as a what? As a table, whereby you have the values in different rows and what? Column. So that kind of data is what? Is a structured data. Structured data are usually stored in relational database, also known as SQL. We'll talk about that part. Most examples of SQL database are Oracle, Postgres, SQL Server, and MySQL. Now, types of NoSQL database, which are unstructured database. Database in multiple formats that are not predefined are referred to as unstructured data. They come in plethora format and cannot conveniently be stored in relational database. For example, music files, images, IoT streams. So you see music file, you cannot store music file in a tabular format. It comes in a different structure. Images come in a different structure. So this kind of data cannot be stored perfectly on an SQL or a structured database. That's why you need another form of database which is called NoSQL, not only SQL. Just like Mongodb, which is a document database. Maybe the data is coming in a JSON file, which is a JavaScript object notation, or a document file. You have Cassandra DB, which stores data in a columnar file. You have Redis that store data in key value. You also have in-memory database. So today we'll just buttress more about relational database. What is a relational database? A relational database is a type of database and is based on relation model of data. This definition from EF code in 1970. So this kind of database is based on what? Relation model, maybe entity and relation model, whereby each of the each table being stored can be related to another table through unique keys, primary keys, foreign keys. Also stores and provide access to data points that are related to one another. To ensure data is always accurate, accessible, relational database follow certain integrity rules. We will talk about that part. Relational model means that the logical data structure, for example, the database tables, the views, indexes are separate from the physical storage structures. Now, in a database, you have objects. There are some logical objects, just like the views, the indexes, the data tables. They are stored separately from the physical storage structure where the data resides on. Data in relational database is organized into tables called relation. So the tables are called relation, and the values there are the entity. So each table can be related to another table. So through there, you can map different table to another table. So as you have relational database, you also have relational database management system. So in this platform, this does like a software that is designed to help out with relational database. A relational database management system is a program that allows you to create, update, and administer a relational database. Most relational database system uses SQL language to access it. So SQL is a structured query language which is used to retrieve data from a relational database system. One of the advantages of relational database, it enhances data security. That means your database is secured at most time because it deals with access to the database. The database is not accessible to an authorized user. Before any user can access the data, the user might be granted certain kind of privilege, maybe a super user privilege, just like a sysadmin privilege, whereby the person can do a lot of changes or a lot of operations on the database. While you can just grant another user just a reader privilege, what that person can only do is just to read data from that particular database. So with this kind of properties from a relational database system, you ensure that your database is secured from unauthorized access. Then retain data consistency. One of the properties of relational database is that even in a time of failure, maybe there's a failure at any point in time, or something goes off, you are sure that your data is still consistent. Your data is consistent at any point in time. We talk about flexibility. It's flexible. You can store different kind of you can have access to different kind of table. You can develop a database model or relational database model. You can scale, add more resource to the RDBMS, increase the memory of the system, of the server, increase the CPU usage, increase the storage capacity, and it's easier to maintain. It's easier to maintain. So when we talk about relational database, one of the things we also consider what we understand by transaction and ACID properties. This is one of the strengths of relational database. So what is a transaction? A transaction is just like a logical unit which access or possibly modify the content of a database. Let's say, for example, you want to make a transfer to a friend having a bank account, normal bank. Then when you log into your mobile application, there's a certain procedure that helps you perform that activities. So what it does is also update your own account, maybe deduct the amount you want to send, and also update the receiver end with the amount you want to send, and insert the logs into a different table. So this, from the begin aspect here, down to the commit part is a transaction, because this body makes changes on the database. This body makes changes on the database. That's what we call a transaction. It's a group of SQL statements that are either or committed, which might mean they are applied to the database, or are rollback, which they are undone. So what they mean here is that if at any point in time, maybe there's a failure at this point, the changes are undone, but this other part will not execute. So that is how a relational database operates. And there are properties of relational database. Talk about atomicity. A transaction is in a unit, or either all transactions succeed or none do not succeed. So if there's any point of failure anywhere, all transactions will be rolled back. Consistency. A transaction must leave the database in a consistent state. So there are certain rules, there are certain constraints. For example, now maybe you have a savings account and you want to transfer above your limit. You just get a response that insufficient balance, because that column there's a constraint that has been placed on that column that it cannot be negative. So these are one of the properties of relational database. Isolation means that each transaction cannot affect another transaction. Let's say, for example, two persons are trying to make transaction on a particular account. Each transaction are handled individually. No one has impact on the other transaction. Then durability. Once the transaction is committed, once the changes are committed on the database, even when there's a power outage or there's a system shut down at any point in time, there will be no changes in that record. The record are consistent even when the system comes up. So these are one of the strengths of relational database, and that's why it's easier to manage and is used in business. So also, relational database has different kind of workload, two major workload: OLTP, online transactional processing workload; OLAP, online analytical processing workload. So online transactional processing workload is more useful for write procedure. What would be my write procedure? Constant updates on the database. For example, banking sector, their database for their banking application are mostly online transactional processing workload, because a particular customer is trying to make transaction, maybe transfer to another customer. There's a changes on the customer account and there's an update on the beneficiary account. So you see that there's constant write on the database, and which is this kind of workload you can run on RDBMS. And another workload too is OLAP. online analytical processes. This basically used for data warehousing. Maybe you want to get analytical view of the kind of data you stored. You want to bring business decision, maybe from the data you have. You want to bring business decision for other activities, like for reporting, for new products, and etc. So this kind of workload, the database is designed to fit online analytical processing workload. So the characteristics of both of them is they handle large number of small transactions for online transactional processing, while for the analytical part, handle more complex queries as high volume of data. So why it handle more complex queries? It's trying to do a lot of analytical process, a lot of join from different tables, and return large volume of data. Now the query is relatively simple, while the other part is complex analytical queries. Most operation on online transactional processing is the select, the update, and insert, mainly insert, mainly changes on the database. Why this one is designed for select queries or data aggregation and reporting. And then use case, usually specific for banking and retail industry, maybe commercial or e-commerce platform like Amazon, for banking platform like GT Bank, First Bank. Online OLTP workload is very important. Then for the OLAP, subject specific, maybe for sales reporting to check the performance of the marketing team or the sales team. For machine learning process, okay, you are trying to build a new product. Then from your data you try to get the relationship or get business idea from the data. So you use an online analytical processing. Then the backup, taken frequently to prevent data loss. One of the major thing operation in online transactional processing is that frequent backup. So that in case there's a failure at any point in time, you can use your backup to bring back the database or rectify the failure. But for this case, since it's more of selects updates, selects workload, data aggregation, you don't have to take backup frequently since there are less frequent updates on the database. Then normalization. OLTP is highly normalized for efficiency. Why? So that you don't have data redundancy. That means data, you don't have same data in different tables. Why this one is denormalized to aid analytics. So how does the workload affect my database? Now, the tables are created in normalized format to prevent repetition. Referential integrity becomes very important in OLTP. Backup strategy is defined by the workload to manage the business impact. Backup is very, very important when it comes to database administration. It's very critical to the business. Then the use of indexes are determined by the workload. So we've talked about how DBMS, relational database. So we'll go down to database as a whole. As a database, and in a database, you have several database objects that are important in maintaining and retrieving information from the database. So you have tables and view. Now, tables are database objects that contain all the data in a database. The data is logically organized in a row and column format similar to a spreadsheet. Just like you have an Excel spreadsheet whereby you have different entries at different rows and a column to give you the attribute. Maybe, for example, in a class, then you take a record of the student's ID number, the first name in the other column, the middle name, the last name, the age, the student's height. So this attribute of each individual can be saved at each column, and their record will be imputed at the row. So now a view is just like a virtual table whose contents are defined by a query from one table or more tables. Now, what the use of a view is just like there's an SQL body or an SQL query that when you call that view, the query is being processed from the database part and the result is being sent to the user. So the advantage of view is that for data security, maybe you don't want unauthorized access to the database. You just give the user privilege to select from that view. So the person cannot see the structure of the table, the person cannot see the data content. What the person cannot get is just the result of the query from the view. To protect data from multiple tables in a simple way, to hide data from unauthorized user by exempting certain columns. Then indexes. Indexes are very, very important in database administration and the performance of a database. An index is a data structure usually used to improve the performance of a database. They are associated with tables and cannot exist on its own. Indexes generally have data structure or B tree to make retrieval fast. So what's an index? Index, for example, just like a book, the back page, whereby you can easily navigate and get to a page. Maybe you want to get a particular definition of a thing in a book. Instead, you just go to the back page, you look through the alphabetical order, maybe just Apple, then it will point down to the page number where you can get the full definition. That's how indexes work. Maybe you want to retrieve a large sum of data. Instead of you just going scanning through the whole book, you just go pick the particular one that is relevant to your search criteria, and then it will point you to the particular table or to the particular page in a book you want to get. Just like in a database table, the index will just point you to the particular row that you need. So indexes are very, very important in database administration. Then you have procedures and functions. A procedure provides a modular way to bundle multiple SQL statements that encapsulate a business logic. While functions are very similar to procedure, however, they are used in more computational contexts. Example, calculating accrued interest for a customer. So the core difference between a function and a procedure, that a function must return a value, while a procedure does not have to return a value. So in this case, a procedure, okay, let's take this for example, maybe you want to make transfer or you want to get your balance. When you go to an ATM machine, you slot in your ATM card, input your PIN and just, okay, let me get my balance. So there's an SQL statement that is being stored up. Instead of you executing it all the time, it's being stored up in the system. And when you click on that function, get business date, that SQL procedure executes and returns the value to you. So that is what a procedure logically means. While a function do some computational stuff. Maybe for example, you want to get the percentage of an employee's salary of every month. So you just define the function in the database, and the function calculates this and return back the value to the user. So SQL, structured query language. Structured query language is used to retrieve data from the database, from our DBMS database majorly. It's used to retrieve data from our DBMS database. So, and we have types of structured query language. You have the DCL, which is data control language. DCL includes commands like grant, revoke. They are generally govern user rights, the permission and controls of the database. So, like I was saying, one of the properties of our DBMS is data security, unauthorized access. So DCL language helps in granting a particular user right to the database, maybe read-only rights, just update on a particular column, some granular privilege, or just backups to take backup on the database, or just to view a particular procedure or view, or have access to a particular table. So DCL language, you grant a user a particular privilege, and you can also revoke that privilege you've granted to that user. Then DML means data manipulation language. This includes all statements used to manipulate the data in the database, from select, update, delete, insert. So select is just for you to, let me retrieve a particular data from a table. Update, to make changes on a particular data in a column. Then delete, to delete a particular row from a table. Then DDL, data definition language. DDL is used to create and modify the structure of objects in a database using a predefined command and a specific syntax. DDL affects the way the data is stored on the disk. So DDL includes create, truncate, drop, alter. So DDL, for example, create can be used to create a function, can be used to create a table, can be used to create a procedure. Truncate can be used to remove all record from a table. Drop can be used to drop or delete a particular table or a particular procedure or function from the database. Alter is used to change the structure of the objects in a database. For example, maybe you want to add a new column to a table. So you use the alter command and add the column. Then TCL, transaction control language. These are used to manage transactions in a database. Example, commit. Maybe when the transaction has been successful, then you commit the changes on the database. Rollback, you roll back changes on the database. Then save point, you save the changes at a particular point. Then backup and restore. Backup and restore is an important activities in database administration. Like a few days ago, we had an issue with data corruption and it affected our business. It was because of we had backup that we had to bring up the database back online for users to use. Backup is very, very important. One of the major activities of the database administration is to make sure backups are taken at the appropriate time and the backup are valid. Backup and recovery is very, very important because any kind of failure can happen because your data is stored in a particular storage. The storage can be faulty and corrupt your data. If you don't have backup, you've lost the data. And when you lose some kind of data, it will affect the business. You can, for example, maybe a particular bank or it's a one bank in Nigeria, and storage got faulty and their data is corrupted and there are no backups. You know the kind of impact it will have on the business. So as a database administrator or database administration, backup and restore is very, very, very important. So in general, backup and recovery refers to various strategy procedure involved in protecting your database against data loss, reconstructing the database, and after any kind of loss. A backup is a copy of your database that can be used to reconstruct the data. So the backup can be hot or cold. So hot backup are taken while the database is actively running, while cold backups are taken while the database has been shut down. So you also have different kind of data backups. You have full backup, you have incremental backup. Full backup is just the backup of your database at that particular point in time, you back it up. Then incremental backup is the changes from the previous full backup to the present point in time. Then differential backups is the changes from your previous full backup to that same point in time. I will explain further on differential backup and incremental backup. Then restore. Restore is also the process of copying data from a backup and applying the transaction log to the data. So restore is what you do with the backup. So when you take your backup, maybe you want to test the integrity of the backup or you want to recover data loss, you restore the backup on a database server or on a database server. So take the backup file and turn it back to a database. That's what the restore does. It takes the backup file and turn it back to a database. So before we go into the lab, is there any question?
Okay, hello, Godwin.
Okay, hello.
Yeah, Godwin, good afternoon. Thank you so much for the impactful teaching. It's kind of a little question. And you said something about index has something to do with a B-tree. So I believe that's an acronym for something. What do you really mean by a B-tree?
It's just the design on how it's being stored, just like a B-tree. A B-tree is a structure of how the index is being stored. Do you understand?
Not really clear. Can we just say it's a tree? Because that B is what I want to get.
Okay, let me get something to just like a B-tree diagram. Just like when you have a child, a node and child node. You understand? Okay. Hi.
Hi, Godwin. This is Ayokunle. So,
okay. Hi there.
A B-tree is basically, I think B stands for balancing. Can you hear me clearly?
Yes.
Hello?
Go ahead.
I don't know if...
Yeah, we can hear you clearly.
Yes, we can hear you.
You can also use all of binary trees. So basically, B-trees can mean binary trees or self-balancing trees. So what it means is that at both sides of each node is supposed to be balanced. For binary, it means there's going to be one to the left and one to the right because it's binary. It's just two. But for balancing, it means there can be multiple to the left and multiple to the right. But basically, the B is for balancing or binary. So I hope that answers your question.
Yeah, that's good. Thank you.
Okay, thank you. Thank you, Akuli. So any other question, please?
Hello, Godwin. Can you hear me?
Hello, I can hear you.
Yeah, this is Nuruddin. I know people may be expecting, probably you talked about the type of database, the SQL and NoSQL, and people are actually, they may not ask the question, but they may be interested in knowing, okay, we have Redis, we have Mongodb, we have MariaDB. When do we use this particular database? When do we use that particular database? I will appreciate if you can also talk about that a little.
Okay, so let me go back to that part. I didn't really address on that part. So now, like I said, a NoSQL depends on the kind of data structure that is coming into the database itself. Okay, so now, for example, maybe the kind of data that you are trying to store in the database comes in a JSON format. You all know what is a JSON format, or a document format, or like a files, like just a document format. We have example of that is MongoDB. MongoDB is very, very important, very, very useful in saving documents or JSON format. MongoDB, CouchDB. Then Cassandra is used to save data in columnar format. Instead of just like, in SQL, you save them, you insert the record in rows and column. But this part, you insert them in columnar format, which is used basically for big data operations, data mining operation, a lot of data engineering process. So that is the importance of Cassandra database. Then you have Redis. Redis is more used for caching. You majorly use for caching, and it saves data in key and value pair. You have a key and you have the value to it, just like you have dictionary in Python. You have the key and you have the value of that key. So it depends on what use case you want to use it for, how the data is being sent to the database. If your data is sent in JSON format, the best database or the best database application to use is MongoDB or CouchDB. Then Cassandra is used basically for columnar store. Redis are used for in-memory or for caching. Hope that's explain, or you understand what I'm trying to say.
Hello. Hello. Good afternoon. Good afternoon. This is now. This in-memory database. What can you elaborate more on that in-memory? I do
Okay.
not really understand.
Okay, when we talk about in-memory database, you know, data can be stored in a disk. Data is majorly stored in a disk, and retrieving from data from a disk is not fast compared to retrieving data from a memory. So in-memory database are okay. These database are not stored in a disk; they are stored in the memory of the server. They are stored in the memory of the server. So in this case, they use it for caching. So it's easier to retrieve the value from the memory, and it's faster to retrieve the value from the memory of the server.
Thank you.
Any other question?
Yeah, okay. Godwin. Yeah, okay. So
Yes.
yeah, so to just buttress on what you just said as regards Redis, which is an in-memory database, you know, yeah. So just like Godwin said, right, it's kind of like an intermediary between your application and your database, because what we have traditionally is that we have so many microservices. Now, microservices are just applications that have been broken down into smaller chunks, right? What we have traditionally is those microservices, right? They communicate directly with your databases, right? Meaning if there's a query that needs, just like the example that Godwin gave the other time as regards the ATM would always have to go to the database to go and fetch data, right? But that in itself is usually slow. That is why sometimes you would find out that you start complaining about things like my application is slow, you know, to be able to return back data. So what Redis has now said is, I want to put Redis in between your microservices and your databases, so that same query that will always go to the DB, right? Your in-memory database would handle that faster, so that you don't always have to go to the DB to go and fetch data, right? The Redis is directly connected to your database, and that would make search to be faster. So Redis is more like an optimization technique, you know, that actually used within the micro service architecture. So that is why for Google, right, if you should browse Google, let's say you want to log on to your email, for example, right? Once you are logging in, you would find out that guy is actually faster. Now, what that means is that there is no direct connectivity with the database at all. There are several Redis cache that are clustered, you know, that would be able to bring your data faster to you as compared to just going directly to the database. Nelson, does that clarify?
Yes, it does.
Right, okay.
But can we say that in-memory database, like from the example that you're trying to make from the ATM machine and all of that, can we say it's more like a hard disk, or can we say it's more like a hard disk, something like that, like
can you say what?
Information stored on a hard disk, you know, it's more on a hard disk now. Hard disk. You use the ATM machine for an example that stores the information where you need to get the account balance and all of that. Yes. Okay, so can we also say it's more like a hard disk? That's the in-memory database.
If I get you right, are you talking about it being installed on a hard disk, or I don't really understand your question?
Okay, no, I'm not saying it.
Maybe you should make a simple scenario like, okay, probably like having many replicas. Maybe that to make it easy for you.
No, you know, you made mention of what's it called? When we talked about the in-memory previously, we talked about it's easily accessible when it's stored in a memory, something like that, unlike on a disk. I think Okwara made such statements earlier.
Okay, I think I think to further aid your understanding, right? It's something that you can always read online so that we don't keep people waiting on the call. So you can just read more on Redis, but really Redis is more like an optimization technique that help applications be able to return data faster as compared to the traditional databases that we have today, right? So you can always read on Redis online, which is actually a new technology, right? Which most organizations use today. So you can always read online so that we don't keep people waiting on the call. Does that help, Nelson?
All right, thank you so much. Thank you.
Yep, you're welcome. Okay, Godwin, can go.
Okay, thank you. Any other question, please?
Excuse me. Good afternoon. Please, what would be the kind of differences between the Redis and kind of a Memcache? Do they do the same thing?
The Redis and what? Memcache?
Yes, Memcache.
Yes, they're actually the same thing. They at least from the word cache, basically what they do is just to cache data to actually make it more popular. So if you go online and then check Redis, those are just the popular open source what is it called, in-memory data stores that you'd find. So they do the same thing. Liman.
Thank you very much.
Okay, thank you for that. Okay, any other question, please? Is there any other question, please? So maybe we'll just start the lab section.
Yeah, we can go ahead. Godwin.
Okay, so in today's lab, we'll be using SQL Server. SQL Server. I don't know how many people has SQL Server from their own end. So Dapo, are we installing it, or I should just go through creating the table and other stuff, right?
Yeah, okay, so we can just go ahead. So when you send in the assignments, right?
Okay.
That's going to be part of what they have to do, to install an SQL on their systems, and then they can just flow along.
Okay, okay.
But can you show them how to install SQL Server, please?
Okay. I don't have a SQL. I didn't download any SQL.
So that should be part of the assignments.
That will be part of the assignment.
Yeah, that will be part of the assignments. Okay. Yes.
Okay, if they just have any issue on that, they can just reach me out, just explain to them. Because I know we don't have much time. I'm just trying to make sure you don't exhaust the time here. Okay, so if you can see my screen can you see my screen?
Yes.
Okay, so this Microsoft SQL Server is an RDBMS RDBMS tool, which is used for relational database management. So this tool here is SSMS, is an IDE for you to do a lot of database administration activities. For example, you want to log into your database. There are different authentication process. So that you use the Windows authentication. You have your Windows user. Then you can connect to the database. It's either you can use your SQL Server authentication. Maybe a user is created on the SQL database with a password, with a username and a password. Then you can log in with that user. Let me try and create a user. Let me create a user. Security logins. Let's say new user. So you grant the password to the user. Password. Then from here you can also determine the kind of privilege. You know, when I was talking about unauthorized access, you can, okay, this user will just have only access to this database, maybe AdventureWorks database, test database. Then what kind of privilege would the user have? A database owner is a super privilege. That is, person can make changes on the database. Maybe let's just grant this user data reader, just to read records from the database. Oh, sorry, let me go to password field, that's not much. Let me type the password in the notepad. So new user. Then in this part, you can map the user to a particular database and grant the user the privilege you want the user to have. Okay, now let's log in with that user. So we use SQL authentication. So, Let me start. Something wrong. I'll check that part later. Okay, let's continue by creating a new database. I'm not sure why that user is not logging in with the password. So the first step is when you log into the server in SQL Server. When you log in, so I log in as with my Windows authentication, to the server. Then from here you can see list of databases. We have AdventureWorks here. This one is taken offline. This is a test database full. So here you can create the kind of database you want. So in creating a database, there are two important things you have to know. Is that you create it from the GUI or you use an SQL statement. And there are two things important: the data file and the log file. The data file and the log file. Let's give the name of database. Let's say our first database. So we can script it out. Now, said what? Create database, the name of the database, contentment none, on the file name. This is the data file. Data file is where the data is being stored on, where the record of data are being stored on. And the extension of the file is MD. MDF extension. The another file that is very important is the log file, transactional log file. Transactional log file, I used to keep the changes made on the database. Maybe should in case there's a failure, the database shut down abruptly. So when the database is trying to recover, it applies those changes to the last point where it was committed. Maybe those changes were not saved on the disk, or they are not saved on the data file. So the tlog applies the changes on the database. So those two parts are very important when creating a new database. So we can now execute, use the master. Now we execute. So let's refresh here. Now we have the database, our new database. When creating a database, it comes with some logical objects like views, system procedures, system views, system procedures, system functions. From here, you can create our new table. We create our new table. You see that you use the GUI, or you use the SQL statement. So let's use the SQL statement to create a new table. So in creating a new table, you say create the name of the table, create table. The name of the table, maybe let's say this is schema. Let's say DBO schema. Person. Then the attributes, let's say identity number, identity ID, or number. This can be integer. The name, the first name. The data type can be varchar, maybe varchar 80. The last name. So now we've created our first table. You come down to the database and refresh. So we have our first table here, which is empty. Is there any question?
Yes. So what do you mean by the schema?
Okay, schema just like a user in the database that is the owner of the object, the table, or the object, let's say table, views, other objects. Maybe a particular owner has the object, or is the owner of that particular object. You can have different schema having their own respective object. Do you understand?
I do not get that. Can you be more clear?
Okay, so what I'm saying, like a schema is like a user that owns an object in the database. Object are tables, object are views, object are procedures, object are functions. So a particular schema is an owner of that object. Like say, when you come to this object now, look at the properties. So you can see the schema, DBO, is the owner of that particular object. Let's pick another database. Let me use AdventureWorks. You have different tables. Now you can see there's a schema here named human resources, and there's an object, let's say shift. This object is a table. The schema is the owner of this particular table.
Okay.
Are you clear?
Yeah. Yeah.
Is that?
Yeah, it's clear.
Okay.
Hello? Yeah, it's clear.
Well, I can. Okay. So now, while creating an object in a database, you will specify the schema and the object you want to create. So like this one, create table, the object, the schema type, DBO schema, which is like a default schema on database. Maybe if you have a user, let me check if there's a user that we can security users here. Okay, let's create a new user here, HR. Okay, so let's create another table with that user HR. That's a job role.
Hello. Hello, good afternoon. Hello.
Hello?
Sorry, I lost connection to the class for a while. This SQL Management Studio. Sorry,
Okay.
was this installed afresh or you already have it on your laptop? Did you show us how to install it?
I already have it on my laptop.
Okay, so how do we install?
Okay, I will send a guide. I'll send a guide on how you can install it on your system. Because if you say we should start installing them, we will not have time to complete the lab.
Okay, no problem. Sorry.
Yeah, Godwin, I think you're having issues with user on this particular instance.
Yes, I guess there's an issue with the user. So
maybe we can just go ahead. Yeah, just neglect users for now. Yeah, so that we can just go ahead with other demos. Okay, I think there is a security. Yeah, we can go ahead.
So the next one is, so you've created the table. You've created the table on the database. Then we move to like inserting records into the table. Let's say you have our table persons. So what do you do? Insert record into the table. You can use the SQL command insert. Okay. Insert into this table. Then the columns you want to insert: identity, number, first name, the last name. Now, what are the values you are trying to insert into the table? So identity number, maybe just a social security number, or an ID number is an integer. You cannot say 2, 3, 4, 2, 1. Then this is a very varchar. The name maybe West. Then the last name Green. So one record has been inserted into the table. How do you check if there's a record on the table? Use the select statement. You can say select all from now this record has been inserted into the table. So you can do multiple inserts. You can do multiple inserts into that same table.
Hello?
Hello? Can you hear me?
Can you hear you? Now, the double quotation and the single quotation, is there a difference between the two?
Okay, there's a difference in between the two. Maybe in case you want to write another statement or a statement inside the double quotation. Okay, let me try and explain it. I'm trying to look for a more better way to explain it. Now, the single quotation helps to denote that this is a variable, a varchar or an nchar. variable just to connote it. Why the double quotation can be used inside the single quotation. Hello, can you hear me? Do you understand?
Yeah, okay. You can go ahead. The reason I'm asking the question, for recently I was learning Python, so I saw that this double quotation and the single quotation. In Python there's no difference, but I think there are other stuff I saw somewhere that there is a difference. So I'm trying to be sure that is there
Okay.
a consequence if you use a double quotation and you use a single quotation when it comes to something like a
for
string.
example, you can use a double quotation as alias. Let me say
Hi Godwin.
Hi.
I think there was a typo when you created the table. So it's FIRTS.
okay, yes.
Yeah, so
That,
that's why
yes.
I'm underlining it.
Oh, thank you. So it depends on the use cases of the double quotation. Most times it can be used as alias. Maybe you want to change the name of a column from the original name. But basically, when you are trying to pass a varchar, use a single quotation or a nchar variable to a database.
Also, can I also add that it's
Okay.
I believe it's advisable to stick to single quotes in SQL, especially in SQL, because there are usually some restrictions around double quotes. You don't want to mess up the database by interchanging quotes using double and single quotes together. So it's best to just stick with single quotes because that's the general acceptable one in SQL. So it's not as robust as scripting language like Python and Co when it comes to quotes. So it's just best to stick to single quotes.
Okay.
Okay. So the next thing is to update records on the table. So update record on the table. For example, we have for example, maybe you want to change the name of the second row, the last name from Kane to Brown. And also okay, just say update the column. Now, the update statement is used to update changes on the database or on a particular table. So you update the particular column, then you can use your where clause to specify the particular role you want to make the changes on. Is there any question on that part?
Okay, Godwin, thank
Okay.
you so much. Actually, my question is not from here. My question is, I remember you stated earlier that this can be done in two ways, one from the GUI and the other from, let's say, command prompt. Can you kind of effect one or two changes or, continue what you're doing this time from a GUI, let's see?
Okay, now from a GUI, you come to the part where you see script. You can create the table, you can drop to create, you can select. Maybe you want to do another insert. So this part just give us the SQL statement to use. Or okay, let's use this chain. Now, this one editing the table, you can add new record here. Maybe you say 2, 3, 4, 2, 5. Then the first name can be Michael. The last name can be Edwin. So when you close it, the data is being saved. So you've inserted into that table with using the GUI platform. So let's do an update. Okay, maybe you want to change the first name and the last name of this identity number. You can also say, okay, the first name might be Caleb, the last name Henry. So the record on that table has been updated. So let me check. So we talk about views. We talk about views on our lecture. We talk about views. So views are just like SQL statements that retrieve data to the user instead of you giving the user access to the particular table. So the user cannot see the structure of the table or have access to some particular kind of data. So you can create view, maybe view, create view, the name of the view, let's say dbu.person, that's called view, as select all from dbu.person. So now you can now select from the view, select all from. So you can see the view just return back the select all statement. So if you go to the database here and refresh, you see that you didn't create any new table. No object was created, just only the view. But if you go to where you have views, you'll see the view here. And when you look at the views, maybe you just want to just see the view just is SQL statement that retrieve data from this particular column. Maybe you want to get data from various table. You want to join the data from various table and retrieve the record back. You can also write a select statement that joins two table as a view. Let's use a database, for example, AdventureWorks. So you have person address. Let's select all. You have the address ID. Okay, maybe for example, okay, you have a person column here. The business entity, the person type, the first name, middle name, and the last name. And you want to get both these details and the person address. So you have a unique key that you can use to pair these two tables. So you can create a view. Maybe person details as, okay, select name. You can select, okay, select first name. Okay. The last name. So now we've created a view that can pick record from two tables. So you can say select all from So now, this is one of the advantage of views. With the aid of views, you can get data from two different tables and return the report as a single table. Any question? So,
Yeah, Godwin, I think we can round up in the next 7 to 8 minutes.
Okay. So, another object we will talk about is a procedure and a function. Like I said, a procedure is just a set of SQL statements that executes on the database. Procedure is just a set of SQL statements that execute on the database. And you can pass in a parameter into that procedure, maybe, and it's an executable function, a SQL statement on the database. So let's pick this. So you can create a procedure, name, select all person address. Then the parameter pass is just, you can get the person address by imputing the city. So select all from, what's the SQL statement? Select all from the person address where the city is. So when you run this procedure, so now you can now execute this procedure. Select all. Let me check. Okay. Now, this procedure does return back the result of the city, Botel city. So when you impute the variable or the parameter, it returns back this records. So that's one of the advantage about procedure. Instead of executing the statement all over again, it is stored on a database and you just need to pass the parameter and you just get your results. A function, like I said, must return a value. A function must return a value. So let's create a function, maybe a function that's return the value of the full name of an individual. Okay, sorry, I don't know, I was muted. Maybe you want to create a function that will return the full name of an individual from this table. You just say, okay, create function, get full name, the two parameters, then returns this in this format as selects the first name, concatenating the last name. So let's okay. So this function returns back the full name of these two columns by concatenating them together. So now the last part we'll talk about is backup and restore. So we have our database. Let's say our first database. Then we take the tags, we back up the database. Then what kind of backup? Is it differential or full database backup? Then we specify the location where we are backing up the data. So the name of our backup first. Okay, that's the extension of backup. Then the option we want to take, can choose different option. Is it append to existing one, overwriting previous backup sets and taking a new one? Are we compressing the backup? Maybe you want to consider space, then you compress your backup. But this time, let's just use the default setting. So now we've taken the backup. Then, for example, we want to restore from our backup. We go to the device where the backup is taken from. Then you have the location. So you have the database backup here. Okay, so it verifies if the backup is valid. Then the file, you can specify the file location of where you want to back up your database and restore your database to. You can determine the name of your database. Since you have our first database, we can restore with the same database. All we just need to do, let us give it a different name, _new. Right. So these are another option. With recovery, that means the database will be open for read-write. Then with no recovery, maybe you still need other database to be applied, other backups, like logs backup to be applied to a point in time. Restore with standby. So these are different options. Then let's restore with recovery. Then when we go to our first database new, then you can see the different objects. Then we take our select statement from here. The record you have in this other database is still here. So that's that on the lab section. Is there any question, please? Hello?
Yeah, well, this is not a question. That backup is where I lost it. I don't know if do we have a few minutes that you can go over the backup for me? I don't know. Because you say you have 8 minutes. I don't know, you think you have exhausted it already.
Yeah, okay. So Godwin, you can actually just quickly go over the backup again so that you can have an overview of what it does.
Okay, so let me take the backup again. So when you come to the database option here, you right click, you see tags, then you go to the backup option. Then in the backup option, you have different options. Is that I don't want to perform a full backup or a differential backup. Now for a full backup, you are taking the full backup at that point in time, not changes to a particular point. Why differential backup? You are taking the changes from this point in time to the previous full backup. So let's take a full backup. Then this part shows where your backup will be saved. Shows where your backup will be saved. You can either change the location of where your backup will be saved, or you can give it a new name. Let's say new DB backup. So the extension of the backup file is .pak. But these are the media option. Maybe append to the existing backup sets, override all existing backup sets, check the media and set the name and the backup expiration period. So the backup option is either you want to compress your backup, or you don't want to use the default setting, or you don't want to compress the backup. Do you understand?
Yes.
So then you click OK. So because the database is not large, the backup has completed. Then if you want to restore restore the backup. We come to tags, we go to restore. So there are two options: is that you restore database or restore files and files group. We took big database backup. We go to the database option. Then we go to our location where the backup was taken and where the backup is saved. So this is a backup. Okay. Okay. So now you can determine where you want the file to be saved. The data file, the location. Maybe you want to change the location. You just say, you click on relocate this. You can choose a different location where your data files will be saved. Maybe let me pick a different location for this. Okay. So then the options, there are different options. Restore with recovery. So restore recovery means you are restoring it to be open for read-write operations. Restore with no recovery, you means you are restoring it and think you will restore another transactional log backup to a point in time. Then restore with standby for standby process. So we are restoring with recovery. Then now the backup failed because you have a database named our first backup. Let's put new database. Now it's restored successfully. So when you come here, you check, you can see the objects, this table are still on the database. Okay.
Okay.
Any question?
Okay. Hello, Godwin.
Yes.
Okay, thanks so much for your class. I really appreciate it. Mine is just on that function.
Okay.
So can't we just call the function and pass those parameters to it without like writing all these select and make reference again to the table? Like say just select maybe all from that function and pass the parameter that you declare, which is the first name and last name.
Okay, maybe that means you will have to, maybe you can do it this way. Select DBO function get so you can pass the name, maybe Grace. Edward. So you can use it, you can use a function like this, but you can pass the function on the particular table, the column on the particular table. It depends on how the use case or on how you want to use that function. Do you understand?
Yes, thank you so much.
Hello, Godwin.
Yes.
Yeah, thank you so much for the insightful class. I'm new to database, so I'm kind of apologies for the questions I'll be asking. May look nonsensical. Please just pardon me. Okay. For the first one, I believe that what we are doing is an instance of a relational database, right?
Yes.
Okay, that's fine. Another question is, can this be done in every other, is that what the labs we are doing now? Can it be done in every other database server, like maybe like let's say like a XAMPP, which I know about that have both database and database server and the other
Okay,
so can we do
like
most of these things apart from doing it on this studio? Can we do some things like this lab in other database server?
yes, you can do it on the relational database server, for example, like Oracle, Postgres, MySQL, but there's a slight difference in their SQL syntax. Do you understand?
Okay.
But there is general SQL, but there's just little difference. So you can create a function in Oracle, you can create a function in MySQL, you can do that in other RDBMS database server.
Okay. Okay. So so if we are to go in, so if someone wants to go into okay, what's the function of this studio? As in this very studio, is it more of like how will I put it now? Is it more of like an application that that can do what every other ones can do, or must it be that one want to go to Oracle, he must use the Oracle server, or you know?
Okay, so this studio is basically designed for SQL Server, SSMS. It's basically designed for SQL Server. It's just an ID for SQL Server. Then for Oracle, Oracle has let me open this one. SQL Developer and PLSQL. Let me share. Let me share. Hold on, please. It's not coming. Okay, for Oracle, Oracle has SQL Developer. Then MySQL has Workbench, MySQL Workbench. That's an ID that you can use to write your queries and do a lot of stuff. Because if you don't have an ID, you cannot be doing it from your command prompt. For example, maybe you want to do it from your command prompt. Now let me open my CMD. Use. Okay, so can you see the screen now?
Yes.
Okay, now this is another ID for Oracle SQL. It's called Oracle SQL Developer. So you can see the connection. You can connect to the Oracle database you want to connect to. I don't know if I have any instance on it to be. Let's see. Let me see if I have any instance. I don't have. I cannot remember any instance currently on this.
Yeah, no problem.
But if there's an instance here, you can. Okay, let me. I think I have this one here. Okay, test. Okay, let me connect. So now. So you can see this one has tables too. This for Oracle. That's table. You can do your okay. Select all from system view. Okay, these are system table. I don't know why I'm not having access to them. So from here now, you can create, let's say, create table. This for Oracle, create table. The name of the table, let's say, person, and name, first name. So the table has been created, they come person. Okay, now this one has empty record. You can now insert into okay, so one role has been inserted. So now this for Oracle database. So you can use similar SQL statements on Oracle, MySQL, Postgres, and SQL Server. So it's not limited to only SQL Server. Do you understand?
Yes, boss. Yes, boss. Thank you so much. Okay, another question is, another question is, can all these actions we perform now, view, functions, procedure, can it be also done from the GUI, or is there an exception?
No, it can be done from the GUI. Depending on the GUI, it can be done from the GUI.
Oh, okay.
So it can be done from the GUI. So just like this Oracle SQL developer. So you can see, you can just come here and create the view name. Let's say this is the view name, person detail, person detail. Then you can now put, okay, select all from person. And you just create you can test your query. Close then, and okay. So you've created the person, you've created that view, person detail. So you see, so everything you can do on SQL Server can be done on this platform.
All right, thank you. Thank you, Godwin. Finally, if you have kind of a PDF file or YouTube link that can help us in our self-learning, that'd be appreciated.
Sure.
Thank you once again.
So I'll share PDF file. Okay.
All right. Thank you so much, Godwin. Can you hear me?
Yes, I can hear you. Thank you.
Okay, so thank you so much, Godwin, for this teaching on database administration, right? Because at first I was wondering how you'd be able to cover all the topics, but really you did justice to it, right? Thank you so much. And, you know, I've actually enjoyed the teaching, especially the difference between OLTP, OLAP, you know, functions, procedures, and all. So, well, thank you so much, Godwin and Kunle. So as usual, the material for this teaching will be posted within our resources page on Discord. So you are expected to work as a team. The different tasks that Godwin would share before the end of today, so that we'll go through the assignments and would assemble back again next week, Sunday. The time is going to be communicated to you between 8 and 9 next week, so that we'll all come again to now present the assignments that would be given to us this evening. So a recording of this will also be available on our YouTube page as usual, right? So this, again, please don't see this as a complex concept, so to say, right? This is just an introductory class. You're expected to take this further by practicing this concept on your own, right, until you get better at it. Now, the use case of this as a DevOps practitioner is, am I going to be the ones to create the tables, to create stored procedures and all of that? No, you are not going to be responsible for that, but it is very important that you know the components of what forms a database. Now, the use case as a DevOps practitioner is, during your CI/CD pipeline, there are changes to the database that developers would have made, right? And those changes need to be updated. Peradventure, maybe there's a schema change or there's a new table that needs to be added for it to accommodate the new changes that developer has made within his or her code, right? All of those changes would have to be passed within your CI/CD pipeline, and they're called queries. Those are the stored procedures, that will be run on the target environment. So you need to understand what those stored procedures do. All of those queries, all the insert command, all the update commands, and what have you, what do they do? What are they really doing? So that you don't just take the query and go and run it. And then at the end of the day, you will now be like, it was the developer or it was the database administrator that gave me the query. You as the DevOps, you need to understand what that query does. Do you understand? Secondly is, if you are running your in-memory DB, such as your Redis, as a container, right? Your application needs to speak directly to that database, be it SQL, be it Redis. They need to communicate with that database. How will they communicate? They communicate via what we call connection string. And you need to ensure that the connection string itself is not revealing your username and password within your Docker file or within your YAML file. So you need to make sure that all of those are converted to secrets. They're encrypted so that, your username and password is not flying everywhere. Do you understand? Secondly is, best practice is saying that, okay, fine, because you know how to operate containers, because you know how to create Docker containers, to run within Kubernetes, and then now go ahead to create an SQL database within a container. Yes, it might work, but best practice is saying that within production, you don't create databases. When I'm talking about databases, I'm talking about the relational databases as a container, because they persist, because they have to persist, and it's not really good to, create persistent activities within a Docker container, because once that Docker container goes down, right, there might be issue. That is why they will always advise you that you should create your DB outside of your container and then connect to it from your, from your container. So all of these best practices are what we'll still be talking about. And that was why we said, let's even talk about databases first. So at least once you are running all of the queries, you will know when and when to use it. And you are going to remember, once you're now working as a DevOps practitioner, maybe like in a foreign organization, that sometimes last year, Godwin taught us how to be able to, extract stored procedures, so that once you see all of those stored procedures, you would understand what it does. You're not expected to be creating tables. You're not expected to be running queries, but you need to understand what it does. And the person that was asking about GUI, right? It's good to, to use GUI, but once you're automating, you are not using GUI for anything. You are writing queries. You're only going to be making use of queries and all. So thank you so much. I don't need to put this into perspective so that at least we know the use cases once we go into DevOps. So I think that will be all for now. Nuruddin, I don't know if my co-founders have one or two things to say. Then let's be reminded of our meeting tomorrow. Okay, sorry, there won't be any team presentation tomorrow. We'll be having the team's presentation on Wednesday. That's for the networking. We'll be having it on Wednesday or Thursday. While these assignments as well, we'll be having this on Sunday. So I think that is just the only information that I have. So Nuruddin, do you have anything to say? Sheon?
Hi,
I don't know.
yeah, okay. No
Fine.
comments from me, actually. I think Godwin did a fantastic job. We tried to break it down. And I'm surprised because when you tell many people to come and take your database, they just come and take you how to run simple SQL queries, how to query database, but it is more than that. And thank you, Godwin. We appreciate your presence, and Ayokunle also thank you for the fantastic job done. So thank you very much. That's all from my end. Hello, are you there? Can anyone hear me?
Okay, yes. All right. Thank you.
Thank you.
Yes, okay. Thank you so much, Godwin. Thank you, Ayokunle. So I will send our Discord link to the both of you so that you can also get on our Discord channel. If there are other questions from our mentees, you can always take them up. All right. Thank you so much, and have a great evening. Bye.
Okay, thank you. I appreciate it.